I want to introduce, we're going to start with our founders panel, and I want to bring back our Dean, Karen Thole, to introduce the panel on from the founders.
Thank you, Henry. I'm going to ask the panelists to come in and have a seat in these comfy chairs up here while we grill you. So while they get seated, I want to point out that these individuals not only bring incredible expertise and depth of knowledge in the field, but they also represent the founders that started really UMTRI. And so we're very happy to have them, welcome them back here representing their institutions. And this started back in 1965. So I'm going to start with just some nice little brief introductions of our panelists so you get to know them a bit. So the format here is I'll introduce the panelists. We've asked them to start out and talk about what are really good ways and important ways that universities and industries can partner. And then we will go through a few other questions, but this is a very active panel, so I invite all of you to participate and think about some questions along the themes of how to work better between universities and industries, what works well, what do we need to work on, and how we can solve these complex problems together. So I'll start with some brief introductions of the panelists. Dr. Paul Krajewski is the Director of Materials and Manufacturing Systems Research at the General Motors Global Research and Development Center, and a global expert in vehicle lightweighting and lightweight materials. He's designed body panels on the 2014 Corvette Stingray. He has had 80 US patents. He's a member of the National Academy of Engineering and an author of over 75 publications, including 3 children's STEM books. He's a double graduate of the University of Michigan, earning his bachelor's and doctorate in materials science and engineering. Emily Frascaroli is the global director of Ford Motor Company's Automotive Safety Engineering Office. She has responsibility for all program safety strategy, including autonomous vehicles, corporate safety policy, advanced strategy development, field service actions, and program safety compliance. Previously, Emily was the managing counsel of the Product Litigation Group, where she advised globally on automotive safety, regulatory, and product liability issues. She was appointed by Governor Whitmer to the Michigan Council on Future Mobility and Electrification, and she taught a class about the legal issues involved with autonomous vehicles as a lecturer at the University of Michigan's Law School. She's also a Michigan engineering alum, earning a master's degree in aerospace engineering. Go blue, okay. As Senior Vice President of Policy, Hilary Cain oversees policy development across the Alliance for Automotive Innovation's entire policy portfolio and manages the policy team to advance the association's policy priorities and objectives. Previously, she held leadership roles at Toyota, where she worked for almost a decade in the U.S. House of Representatives and was recognized as one of the 100 leading women in North America auto industry by Automotive News in 2025. While not a UM alum,
I'm sorry.
It's okay. Hilary and I do share an alma mater of the University of Texas, where she earned a master's degree in public affairs. Hook 'em. All right, now let's get started. Across the college, as I said earlier, we are anxious to work closely with industry in solving some complex problems and continue our very important partnerships, especially amid today's uncertainty in everything we're doing on the research front. So I would like to invite each of you to talk about your organizations, how you decide when a partnership works with a university, which we're competitive between universities, and so how this all fits together in your overall technology roadmap. When do you call out to universities and work together? So we'll start. We're going to go alphabetical. So Hilary, you're up first.
All right. So thank you so much for having all of us, and particularly me today. I'm starting, but I'm going to be, I think, the odd man out or odd woman out in this, because my organization is primarily focused on government policy, right? So our role is to represent the auto industry in Washington, D.C. and state capitals around the country and encourage policymakers to adopt policies that support the competitiveness and health of the auto industry in the U.S. and discourage them from adopting policies that do the opposite, okay? And so I'm not developing technology. Our association is not a technology developer. We work, for and on behalf of companies like GM and Ford that are doing technology development. So our needs are a little bit unique than maybe the needs of a particular auto company. But I wanted to give you a sense of the sorts of research that we need as an association, and university partners can fill those needs for us from time to time. So the first one is, and this is one that is maybe a little more of a stretch, but I would call it policy research. So this is analyzing the impacts of particular policies or proposals on the auto industry. That's one thing that we do a lot. We need that work a lot. Someone proposes puts a proposal out there, and we need to understand what kind of an impact it would have on the industry. The second is what I would call sort of problem identification or quantification. Policymakers are really, really interested in getting their hands into a whole lot of areas, and they'll express interest in regulating or legislating in a particular area, and we want to be able to tell them whether there is a problem that they need to solve or there's not a problem that they need to solve. And this happens all the time in the automotive safety space. Some legislator gets the idea that they want to mandate a particular technology, or they want to ban a particular technology because they think there's a problem, and we need to be able to go back to them and give them research and data that shows yes, they're right, or no, they're wrong. Does that make sense? The third I put down was evaluating new and emerging technology. I would characterize this as sort of technology assessments or technology readiness assessments. Same kind of idea, right? If I'm a policymaker and I want to mandate a particular technology, and we as an auto industry don't think that technology maybe is quite ready, we want to be able to show them research that demonstrates that, or vice versa. And I think the connected vehicle pilot was a great example of this, in that there was a technology that we as an industry were promoting and wanting to advance and get policymakers excited about and bought into, and we needed data and research to show the potential safety benefits of the technology. I've got two more and then I'll stop. The fourth is, and this is a little bit different, sometimes, believe it or not, government does not know best, and industry is in a better position to, I would argue, bind together and come up with a path forward, whether it's a technology deployment pathway that may be better situated to do it on our own. And so sometimes we will look to universities and research partners to help us figure out sort of a voluntary industry-led deployment pathway as a alternative to a policy prescriptive sort of roadmap, if you will. And then the last thing, and this is something I just wanted to flag for you, maybe we'll have a chance to talk about it, because I think we'll talk about government, federal government, and the challenges it's facing right now, and funding limitations. But I've had an opportunity to visit recently with new leadership over at the National Highway Traffic Safety Administration. And I don't think I'm going out of school by saying that they lost a lot of really good research capability within that agency. And they recognize, and this is part of the, RIFs and all that sort of stuff. So they recognize that they are going to be challenged in the next several years to do the research that they normally would have done in-house. And so they have indicated to us that they are going to be more reliant on industry than ever before to help them do the research that they need to do to be able to support their motor vehicle safety standards development, for example. And I think industry is going to have to partner with folks like you all to help us do that research so that we can give NHTSA what it needs to be able to do regulation in a responsible way. So I'll stop there.
Emily?
Well, good morning, everybody. I'm so thrilled to be here today to celebrate the 60th anniversary of UMTRI. I can't believe that. I wasn't here when that happened, but I'm very proud to be here representing Ford, along with GM and Innovators as the original grantees for that. I mean, that's amazing. I can't believe we're also celebrating the 10th anniversary of UMCity. I'm gonna talk about that in a second because that has particular personal meaning for me. And it just reflective of Ford's longstanding commitment to safety and innovation going back 60 years. I think our partnership with U of M goes back even further than that. And so that's an incredible milestone to be able to be here and celebrate with all of you today. To talk about sort of the question you posed about how industry and universities can work together, I do want to talk about the UMCity example because I think it's a really good example of an area where there was tremendous uncertainty, technology was on the cutting edge of development, and there were a wide range of issues, not just technical issues that needed to be addressed. And that's why UMCity was formed, to address a whole range of different things, including policy-related issues. So I remember 10 years ago when Greg Stevens, who's sitting here in the front row and who now works at UMCity, called me and said, hey, do you want to come be on this legal and insurance working group at UMCity? They're going to work on legal and insurance and policy-related issues for autonomous vehicles. And I said, sure. And somehow I ended up co-chairing that group, and we had the brilliant idea that we needed to train future lawyers on how to deal with a lot of the legal issues that were developing and were a really heavy topic at the time. Consequently, I somehow ended up teaching that class at the University of Michigan Law School. But it was an amazing opportunity, and it is a really good example of how multidisciplinary groups can come together in an academic environment and create real change. I had students that went on to work at NHTSA in rulemaking on autonomous vehicles. I have students who are working as lawyers at technology companies and really making a lasting impact on advancing the technology, both from a technical and policy perspective. So I think that multidisciplinary approach in areas of high uncertainty is a perfect place for universities and industry to collaborate.
Paul?
All right, so thank you very much for the opportunity. Just like my panelists here, super excited to be here, to be part of this, to be part of the history of UMTRI, and have the opportunity to collaborate with Henry a lot on projects recently. Really appreciate that. And this topic is really important to me. I'm the product of a university industry collaboration. My PhD was funded by Ford, actually.
You're welcome.
So thank you, yes. And so I had that opportunity to go to grad school because it was a partnership, a longstanding partnership that existed. And so when I was thinking about this, I have a little cheat sheet that I brought of like, how do we collaborate with universities? And so it's a pretty huge list of the different type of ways you can do this. So you could hire a student professor, work on their PhD, part of a consortia like this, a goalie, NSF goalie grant, very specific contract deliverables, or something that's like a user facility. I come use a microscope, I come do something like that. We partner with government, US CAR, so I have a role with them. We'll write support letters for proposals that you're putting in. We've hosted visiting scientists on sabbaticals, interns. I was a summer intern a long time ago at GM before I was funded by Ford. Come and teach lectures at class as well. Senior design, capstone projects. CRADAs, government collaboration. We've done a lot of stuff in the US, in Canada with NSERC, with others. License agreements. I participated in MTRAC, so that's a way to get innovation from universities to industry. People are adjunct professors and advisory boards. So there's a whole bunch of ways that industry can collaborate with universities, and then the question is, how do you do that? And so what we'll try and do is, in a specific technology area, understand what do we want to achieve? What's kind of the end goal on the roadmap? And then you have to figure out, how do I get there? And depending on the problem we're trying to solve, you'll either look for a consortium, and I can give examples where if I'm looking at transportation, I'll come to a consortia here. If I'm looking for a specific professor who has a piece of academic knowledge that we need, I might go to some place. We have a project at Kent State and other places because there's a professor with a very unique skill that is relevant to a problem we're trying to solve. And the one thing that I'll say with a lot of these, it comes down to relationships. So the fact that a person knows a professor, you have a relationship, they're the ones that could ask for a letter, come talk to my class. Now that turns into a project, and those relationships become the foundation for a lot of these collaborations.
Thank you all. So, I think each of you touched on this just slightly, and I think Hilary actually maybe talked about it a little bit more, but, we are sensing there's, of course, a lot of uncertainty in federal funding and a lot of uncertainty in almost our daily lives these days. And one of the things that we're sensing at the university is to go faster and to deploy solutions faster, real solutions. And sort of almost a little bit of a shift away from some of the basic science that we do at universities, which I think has fueled, many developments. But I'd like to get your take on that, and if our reading of the tea leaves is right, or how you think about sort of this idea between what universities should focus on, the basic science, or hey, let's get to a product and an implementation. And I know MCity and UMTRI are like terrific at doing real stuff, right? But still, at some point, we do tend to work on basic science and solutions. So I'd like to get your opinions on that topic.
Yeah, I mean, I can jump in and say yes. So from our perspective, one of the challenges that we have is the policy space is really, really slow, and then really fast, right? And when it's fast, we've got people, we've got legislators, we've got regulators who are trying to do something, and we need the research quickly to be able to give them information to maybe channel their energy in a different direction or to double down on what they're trying to do. And oftentimes we find, we need the research sort of yesterday. And we'll talk to research partners and it's like, well, we can get you an answer in 18 to 24 months. And that's not a timeline that sort of works for our needs. So I do, at the same time though, good God, like what a shame, right? If the universities can't do the basic research. So I don't envy the position that you all are in. I don't envy trying to find that right balance, but I do think maybe that's the key. It's gotta be some sort of balance between the quick and dirty and the sort of longer term, more strategic basic research.
Yeah, I would agree. I have to consult with a lot of the researchers in my lab who are asking, what's important, getting something on a car or publishing a paper? And it's like, both, right? You're a researcher, you have to do the fundamental research. And so I think the biggest challenge for us in the university is how to fund that, right? We've been part of things where we'll fund a PhD for 3-4 years. It's really hard to get that consistent funding. So that's where if there's ways to partner either through a consortia or with some government funding that you could do a little bit longer, that really helps. But then there's a piece of it where, we did an example here at U of M with, we called it an innovation incubator. There was kind of a senior design project, and you would just be engaged with the students and see what came out in that semester. And if there's something interesting, that would turn into a project or become something that we would leverage at the company. And so you have to do some of both. We're all feeling that urgency, absolutely, but we also recognize you have to do the fundamentals of the science or there's really no purpose in existing.
Right.
Yeah, I might just add, nobody would say don't do the fundamentals and the science. We have to have that. We have to make data-driven decisions and use facts and science. But in general, the product cycle for the automotive industry has changed over the last 20 years, where a program, might have used to have been 5 to 7 years. We're much shorter now. Consumers are expecting new technology and updates and advances on a much quicker pace than we're used to working. And so maybe the luxury of spending a long time working on something, we don't have that anymore. And that's just a reality of the industry.
Yeah, and I'll say, just to add to that, it's very domain-based, right? So where I started my career, I am now, in materials, and you're looking at structures, there's a much longer time horizon, right? You don't just change a body structure like that. But as we moved to software-defined vehicles and AI, those tools could be implemented much quicker. And so that turnaround, they don't have roadmaps that go for 10 years because you don't even know what's going to be available in 5. So it's a much different time scale in some domains than in others.
So I'm going to change streams a little bit. Paul, you talked about when in your remarks that a best way to work with universities, like how to start, give a lecture in a class, and it builds on a discussion and it builds from there. I'd like to know any other best practices from all the panelists that we can use in working with between university and industry. What are some really best practices we could learn from you all on?
I think it's collaboration and that relationship piece. So the best collaborator I had was from the University of Texas, a partner of mine I worked with. We met at a conference. He gave a talk, I gave a talk. I was like, wow, that's really interesting. And we talked, and then we funded some work, and then he came and visited, and we just built this relationship. We'd go for joint funding, and that relationship over time, we have multiple graduate students, and it just kind of builds upon itself. And it really starts with that one-to-one relationship and partnership where you're kind of co-collaborators and not something where, hey, I'm a professor, just give me the money and I'll come back with a result later, right? I've never seen that work very well. It's when you have that partnership and collaboration, you spend time in their lab, your students come spend time in our lab, that's when you could really make a difference.
Yeah, I might just add that I think what you're alluding to is also trust, like having established relationships where people trust and you can have a free flow of information and you have high confidence that the money you're investing is going to return on something. And I think maybe the other point I just would add is being really clear and specific about what the objectives are. It's super fun to work on stuff that's really ambiguous and open-ended, but for industry, we need to have clear deliverables and what the expectations are. And I think that's a really strong best practice.
Yeah, I don't think I have anything to add. I agree with everything you said, particularly that last point that you made, Emily. I do think, when I've had an opportunity to do some engagement and research work with research partners, including universities, sometimes it is challenging and that there's something I need, and then the partner has a different sort of idea of what they could do, and I appreciate what they're thinking about, and that sounds really great, but that's not really what I need, and then it becomes complicated and more tension-filled than it maybe needs to be.
Yeah, and there's almost an extension of that. I've had a couple contracts where we don't go back to that university again because maybe the professors can't get along, right? I'm not going to work with this. I can't use their lab, and it just becomes all this internal turmoil it's just not helpful, right? If you could find a way to get along, agree on what you're going to deliver, it's so much more helpful. And that makes us want to come back with the precious dollars that we have to spend at a university because we get something and we really have kind of partners to work with.
These are all really excellent points. I have worked in my entire career with industry, and I think, I resonate with all your remarks. The other aspect, we have some students in the room, right? And we've talked about faculty and labs and whatnot. We hope that these students also become very involved in these university-industry collaborations. And so what tips might you give the students to, work in kind of a relationship with that? Because students are here, they take classes, they're focused on, getting their homework done and whatnot, and yet, you've got an industry sponsor who needs a result tomorrow. So it's, it's stressful. It can be stressful for a student if not properly managed, but I'm kind of curious to get your take on what are best practices to work with students in these kind of relationships? Any thoughts there?
Go ahead, Paul.
Yeah, we're looking at Paul.
So I think one of the ones is, as a student, don't be afraid to reach out and connect, and kind of force your advisor and maybe your industry partner meet on a weekly basis to check in and see what's going on and have that discussion, so you're not going in a direction that is not what the project is either set out for or what the customer wants. But have that discussion. It's okay. I'll sit in some of these meetings and the students, I've been in some where the students will sit there and they're kind of sweating and nervous, and it's like, just talk to us. We're just like you. We're students just like you. Just talk, and you could have those regular interactions. I think those are so important, and I've done those even with summer interns after they're an intern back at the university. Have those check-ins with the professor. Super powerful. That communication is huge.
I would add just, don't be afraid to express bold ideas. One of the things I learned through my 7 or 8 years of teaching was that a lot of my students were way smarter than me and could come up with ideas that I had never even considered or spent 2 minutes thinking about. So if you have a cool idea or something novel or different, don't be afraid to throw it in the mix. Not every idea is going to get a warm embrace, but some of them will. So don't be afraid.
Yeah, and so to the students that are here, in addition to that, the single biggest thing that you could work on as a student to get ready to engage is your communication skills. Yeah. If you can tell a story really crisply and explain your research, what you're trying to achieve, so that your parents could understand it, that goes so far in terms of being able to communicate to anybody and sell your ideas.
Some of the best ideas have not surfaced because somebody wasn't able to talk about them very well.
Right.
So that's really, really good advice.
Hilary, do you have any?
I don't think so.
Okay. I mean, and the communication, I would totally agree with that. I mean, I think, and these partnerships between universities and industry are so beneficial because our students get that opportunity to have to communicate their work to an outside audience, which is terrific. I have a lot more questions here, but I want to give the audience a chance to ask some important questions to our panelists. So I think there are microphones running around the room, so I'm going to put you all on the spot now. Do you have any questions for our panelists? Please introduce yourself so we know who's in the room. It's very helpful.
I'm Dick Bobian. I got a degree from Rural Fishing. We have defunded the police. We have legalized marijuana. And we wonder that has a negative impact on traffic safety, I believe. So some of the people we should be talking to are the first responders, even the police. And they're not at the table. How do we get them in the game? My experience as a traffic engineer for the city of Troy in the past was that I learned a lot from the cops about how things are working or not working. And I think we need to get that communication established and get the first responders in the game. I'm also learning some things from fire chiefs too, but police are a good place to start, and we need to think about getting in the game.
I think that's a great comment. I had some interesting discussions even this morning with John talking about insurance companies as well, what their feedback is. And there are pockets that do that well. So in the area of materials, they've done a lot to talk to first responders on how do I design for my jaws of life can't cut through the high strength steel that's in your B pillar. What does that mean? And so there's been pockets of that, but that kind of insight helps affect design, safe design, all kinds of things. There's a lot of truth in what you say.
Yeah, so just an observation. When I was reading in preparation for today's event, reading back through the history of UMTRI, and when reading about how when the organization was formed, that it was focused on analyzing the elements of the complex and dynamic systems of people, vehicles, and environments. And what struck me is this was safe systems before safe systems was a thing, right? This idea of all of these pieces coming together to make roadway safety, to improve roadway safety. And certainly as you look now at the safe systems model, enforcement is a key part of that. And that is something that I do believe, in my personal opinion, has been lacking of late. I sense that there is a recognition that that is a critical piece of this puzzle and needs to be back in the mix. And I think there is some changing perspectives on that, but I think you're 100% right. It's all of the things, and enforcement is certainly a piece of it.
I might add, Ford has our police advisory board where we have a really close relationship with a lot of our customers that use our vehicles and have feedback channels with them about technology and other things that they need. And then in my bio, it was mentioned Governor Whitmer has the Council on Future Mobility and Electrification. So that includes industry, but it also includes Michigan State Police, or members of that. And that's been a great group to have collaboration between industry, policymakers, and law enforcement on issues related to mobility and electrification. So I totally agree with you, and I think there are some things going on in that space.
All right, do we have another question from the audience?
Hi, my name is Jingwen Hu. I'm a research professor at UMTRI and also a professor at IOE. Thank you for being the panelist here. Over the years, I'm very lucky to actually cultivate very close relationship with both GM and Ford researchers. When I think back, I couldn't think about how I actually cultivated that. I didn't reflect enough to actually give any advice to the junior faculty member to say how you actually cultivate that relationship. Do you have any suggestions for, let's say, junior faculty member, they don't have that relationship yet, and how we actually do that?
I think a couple things is leveraging the network. As you talk a lot about mentorship as a senior faculty member, introduce those junior faculty members into your network to help with that. And your network and their network evolves with their students as well, right? So I come back and give a lecture in my former advisor's class because we have that network. And so you kind of build that up there as well. I think that's I think a big role of mentorship. And we talk about this at work as I may have somebody who's part of SAE or IEEE standards or something like that. Okay, you're the person who's doing that. Who's next? How do you take that person to the meeting with you, get them engaged, and bring that along? And so I think that becomes a big role of the senior faculty to really help bring those young ones into your network to help foster those relationships.
I mean, I think the other piece of advice is very rarely do opportunities just come to you. Maybe you'll get really lucky and somebody will say, hey, do you want to work on this great thing? But people have to be proactive and go and look, right? Learn about the issues industry is facing. And if you're interested in that, find the niche, find the thing that's going to be appealing, and then find a way to get to somebody who will listen to your idea. But being brilliant is not enough. You have to go and look for the opportunities.
Other questions? Yeah, we have one up here.
Yeah, Dave McNamara with former Ford Spirosop right now. Thank you, Hilary, for your comments on the ways to engage. I thought that was a very good list. And just a shout out to the radiation lab. I worked with them in the 80s, and we were trying to figure out, we're putting an electronic compass in a car, and do we have to demagnetize the whole car? Okay, that shows you the level of understanding we had, and it was very helpful. Very short project. And it was dealing with a very practical, very urgent problem. We had actually assembly line shut down, so that was a very good example to provide us. So my question is around really more the metrics. Like what are our expectations over the time frame for basic research versus a problem solving? My experience was months, you know, well, probably wasn't a month, but you know, where we had to get help on a practical problem. So what's the spectrum of engagement as far as the time frame?
Yeah, and I would add one more, actually moving new technology into a product. So going from basic research, I think that's a great question.
Yeah, I mean, I'll start with the sort of the time frame. I mean, it's hard. I mean, sometimes it is as fast as a month, right? You know, when we're doing, you know, thinking through some of, like I was talking about, how I think there's going to be an opportunity for industry and partners like universities to help support some of the research that NHTSA had traditionally done in the past and maybe won't be able to do now. There's a little bit more time on that. Rulemaking doesn't sort of happen, you know, very quickly. So there's, you know, in those cases, you know, year or 2 or 3, right, of research that can go into it. But when you're talking about a member of Congress or a state legislator trying to mandate something kooky or, you know, that's a very quick turnaround in order to get them the information that they need to sort of understand what they're getting into.
And I don't think there's a one-size-fits-all. It depends a lot on, you know, what it is that you're talking about. If you're working on a project that for an OEM represents like a clear competitive advantage and a technology that's going to be new and really benefit the automaker, the expectations are going to be much shorter than some of like the bigger gnarly problems we have to work on, like automation or connectivity, where those things might, they require a lot of moving pieces to come together at the same time, and maybe the time frame for that type of work is a much longer horizon.
Yeah, and I think also this difference in domains, you know, I mentioned it before, but in the software space, you know, some of the work that actually my team and partnered here with Henry, we've been able to optimize traffic lights in cities pretty quickly, and that happens. But if I'm coming up with a new material for could be a wheel or, you know, whatever that is, the first thing is we don't make those. So you have to have a tier 1 supplier or a tier 2 supplier, in some cases even more, all the way up. So there's a very complex supply chain to take that idea, then partner with somebody, and then they need to provide it for us. So that drives some of that time there as well. And then, you know, there's always if it's important to us, how do you deal with IP? What's the IP arrangement with the university that you're working with, and how do you capture that? And so that's, it's complicated. You know, I saw a lot of this when I was on the UMTRI board of trying to get an idea, then a professor has a startup, and then they've got to find somebody to invest in that startup, and often those steps will take quite a while, especially if it's hardware-based.
You know, you just said something that prompted a thought for me. So we've been obviously we're talking about GM and Ford because you guys are on the stage and you're original, you know, funders of UMTRI, and everyone wants to work with GM and Ford because you're big and you're sexy and all that stuff. But you just talked about suppliers, and we were talking about how to break into sort of, you know, this space and make a name for yourself. I think it's also, I mean, everyone in this room knows, right, how critical of a role the suppliers play in this ecosystem, and so there may also be opportunities. I would assume to get in and work with suppliers rather than only with GM and Ford, right?
Yeah. So did you want to say anything to that, or no? Okay. Okay, so let me while we're on this topic though, I have to ask, right? How is AI changing things in your industries and how you are doing things? Like, is it, you know, affecting your processes? Is it affecting the science or the technology that you develop? Or, you know, how is it being used? And are you embracing it? Where are we on the auto industry?
Okay, I will say it's everywhere.
Yeah.
And as a leader at R&D, my previous team on connectivity and the current one on materials, every project has some aspect of AI or large language models or something that we're using. So, you know, a couple of examples, we're doing some things in the plant right now on inspection. where I want to know if I have a quality weld say a door, one of the examples we've talked about recently. And this is very much like the healthcare industry looks at inspection for melanoma or other things, right? I do image analysis, leverage tools to say, is that person in danger? We're doing the same thing with welds. I'm correlating the science behind can I make a good weld with what it looks like. So I have an optical system, real-time inspecting things. There's an algorithm to look at that, extract that data, and then be able to predict or correlate what it's going to look like. So there's examples like that, all the way to all of the stuff in autonomous driving and in other things. We are leveraging AI tools in pretty much everything we do.
I also think this is another great example of one of those multidisciplinary problems, right? So there's the technology of AI and how you use it and what you're developing and what new things that are coming up. But there's also a whole host of other issues that come along. There's ethical issues, there's legal issues. Regulators are considering, how to put frameworks in place to govern AI. So this is another example of an area where, a university like Michigan can contribute on a multidisciplinary approach and have people working together on problem solving, particularly in some of those policy areas and things like that. So it's not just a technology thing.
Yeah, I would say, we are certainly cognizant at Alliance for Automotive Innovation about how much integration of AI there is in what the auto companies are doing and in the products that they are making. And so, I'll just pick up on something you just said, Emily, which is there is a lot of policymaker and government interest in AI. Some of it is government's excited and they want to, help sort of cement U.S. leadership in this space and promote innovation. And then there are other policymakers who are scared out of their mind and want to do everything that they can to slow this down. And so what we are doing, or what we are trying to do as an association, is help tell the story of what this means to the auto industry, what it may mean for the auto industry, and at least make sure that we are part of the stakeholder community that's being consulted as policymakers are thinking about what frameworks to put in place, and realize that this is not just about ChatGPT. It's about potentially better safety technologies in vehicles and things like that maybe are not front of mind for them as they're thinking about regulating in this space.
Yeah, and one thing that I'll add kind of goes back to your earlier comment about science at the universities. We get this question all the time, what are you doing in AI? What are you doing in AI? And it's quickly becoming, it's not different than Python or Excel. It's just a tool, right? You need the deep domain knowledge in whatever area you're working in to apply that to the right problem. And if you don't have it, then you're not going to get the right answer. You're not going to have the right data. So it almost emphasizes more the need for the fundamental scientific knowledge or physics or whatever it is to be able to leverage those tools.
Paul, I think that's a great example. I was thinking about your weld example, and the question I have is, are we up against not having enough data to really make these models go even further, or have we not yet reached that?
No, I think that there's a mix, and so what you're seeing is, one is you got to have data. You got to have good, clean data. That's a huge challenge in all of these different areas. But we're now seeing people trying to leverage simulation to create artificial data that I could then train my models on. And there's opportunities there as well, as long as, because in many of these, especially in autonomy, the corner cases are what drive all of the challenges. So if you can't experience all those, are there ways that you can simulate them to then maybe help train models as well?
I think this is a prime spot for universities, right? In actually helping to generate data to actually move those models forward. Okay, I know I've been asking lots of questions, and Henry has a question. Go ahead.
I have a question. I think I want to follow Thole's question. I have a question I have to ask. 60 years ago, you founded UMTRI with $10 million gifts to the University of Michigan. Now, how we can get you to invest $100 million at the University of Michigan.
Wow.
I love the directness of that
Paul, did
answer,
you
of
bring
that
your
question.
checkbook?
I don't think I have that. We would love to do more and more work at universities, and it's just the challenge of finding the money, the consistent stream of money, and then I think the big thing is being able to define the value proposition of what you're trying to do to justify it. And that's, it's in the world of safety 60 years ago, I'm sure it was very easy to justify that. And now it's, what does that look like today? What's the right problems?
Yeah, I mean, and I'll just say, and we talked about this, I think, last week when we were together, and you all know this as well as I do, but right now, things are real rough. It's rough to be in the auto industry right now. I mean, I've only been in the industry 13 years, which means I'm a baby compared to a lot of folks, in this room. But I certainly haven't seen the industry under as much stress, prior to this. Like this is a lot. So I just mentioned that because hopefully this is a blip. Hopefully this is a blip and things will be beautiful and wonderful and there won't be as much stress a year or two or three or four from now. But right now is a rough time for all of the auto companies and for the industry as a whole. There's not a lot of extra piles of cash sitting around.
Right, and that's where you need to be creative about the consortia and the partnerships. And we Ford and us and Stellantis, we lead U.S. cars, so we all put in some money and get 3x that or more of that because we're able to leverage. And so trying to come up with those right partnerships where you could get resources from different teams to help do that. The other one, you mentioned the dollar piece, we're all still struggling with human resources as well. Like with a lot of things, we need in kind. And we have fewer people than we had before, so it makes it more difficult to even do some of those kind of things where you need, the ability to get 50% in-kind funding.
Other question up here in the front.
Vicky, we're over here.
Oh, wait a minute.
Hi.
Over there, and then we'll go up here.
I'm trying to jump in as quick as possible. You brought up a point that leads into my question. Thank you for that segue. I'm here representing the University of Michigan Center for Innovation in Detroit. My question is about human capital and what kind of research and what kind of opportunities could we have between industry and the university in developing the jobs of the future so that we can keep people in Southeast Michigan.
Yeah, I'm glad you brought that up. I mean, I think that's the huge piece of being involved with universities is the students.
Yeah.
And getting the students to come and drive the future of the automobile industry. And as OEMs here, trying to figure that with U of M and the other schools around us, that's how you get people to stay, right? They grew up here, their spouse is here, something like that. That's why you stay. That's why I stayed, right? So how do we get those kids excited about science and educated so that they want to stay and continue to grow? It's a great point, and I think merits a lot more discussion. I'd love to hear more about the Detroit Center, too. I have no kind of on the periphery. I'm excited that that's going to happen. All right.
What are you looking for in today's student that maybe is new and wasn't there 60 years ago?
I think the multidisciplinary piece is big. Right?
Okay.
The ability to work in different disciplines. I said the physics deep knowledge in something is important, but being aware of how to leverage either different coding techniques or different AI techniques or be able to work, so many of these problems. If I'm developing a new display, I need the connectivity people, I need the display people, I need the materials people, I need mechanical engineers, software, all of that has to happen in order to launch one of those parts. So those researchers that can cross all those domains and then speak and communicate well, super important.
Emily, do you have any comments about that?
No, I mean, my thoughts are along the same lines as Paul. Like, having students that are able to see multiple facets of a problem instead of focusing maybe narrowly on solving, a technology problem. Not everybody's going to be like me. I started in a technical path, and then I went to law school, and now I'm back on the engineering side of things. But having that rounded approach and ability to see the technical issues, the legal issues, the policy issues, the ethical issues, different aspects of problems, though we need very deep technical researchers, but we also need people that can see sort of the bigger problem.
So
I
Hilary,
was going to say, I also think, and I thought this as long as I've been in the industry, we as an industry just need to do a better job of telling our story. And by that, stick with me for a second, because we are competing as an auto industry, right, with for the same talent that the big fancy tech companies are. Like, for example, if I'm a student and I want to get into, like, I don't know, AI, right? Like, the auto industry is probably not the first industry I think about, right? When I think about what I want to do, I want to go work for, I don't know, all the whatever, right? The AI companies. And so, if we want to attract talent and get people excited about what possibilities are here, we have to do a better job of explaining, like, what's on the horizon and what kind of talent we need, and make this like a end goal for students. And I think we are pretty insular and don't do that great of a job of sort of telling a story broadly.
So maybe I could turn that question back to Henry. With a 60-year legacy of all the technology and the type of students and all that, how do we tell that story better and get high school kids and others excited about this as a place to do really fun work and impact people? I think there's probably some.
I guess you give the university $100 million.
There you go. Okay, there you go.
But I wanted Hilary. You work in policy space, and that's generally. It's not to say that we don't always do this, but it's students don't think about policy and engineering. Is that really an important piece and sort of a knowledge base that you look for when you hire people?
Oh, for sure. Yeah, and I do think, policy and government has a huge impact, right, on what we do and how we do it, and whether we're going to be successful or whether we're not. And we do need good people who understand the industry and understand the technology and understand the law and understand policy that can help explain what all of this means or doesn't mean for the industry. So yeah, I think it's, I don't think it's, at the end of the day, as important as working on all of the amazing technology that goes into vehicles, but I think it's a very, very, very important part and very significant in terms of the success of this industry going forward.
Henry, I didn't mean to cut you off. If you have an answer to Paul's question, go ahead. I just thought I'd help you there.
I think one of the comments I want to make is that when they ask $100 million question, really what I meant is UMTRI or other transportation institute want to be part of your solution, to build together with you to handle these challenges. I know auto industry is really high pressure at the moment. There's a lot of technological changes and movement, whether it's AI, whether automation, connectivity, there's a lot of these. There's a lot of global competition on the auto industry as well. So what I'm trying to say is UMTRI and other transportation or automotive research institute, we want to be part of your solution. Yeah. We want to be helping you, and we work together to invest into the future. That's actually what I meant. And then we want to sort of, we send students to you. We work on long-term challenging project. And Paul, we have been working together on some of these things, and I see the results when we work together. And so that was really the comments I had.
Yeah, I did bury the lead on something, so maybe I'll mention it now as good a time as any. So we are, at least at Alliance for Automotive Innovation, trying to figure out how to, we're focused on figuring out how to build stronger relationships with universities and academia and how to partner going forward. So we're in the process of forming an academic council where we can have sort of academic expertise on technology, safety, environmental policy. We can dialogue on trends and challenges, and we can figure out, most importantly, how to engage academia more. So that is something that we are in the process of forming. I don't believe, as of right now, we have a University of Michigan voice on that council. So I think there's probably potential there. It seems like a glaring omission, in my opinion. And then the other thing we're doing is we have piloted, and again, I mean, it's weird that this is not initially with this university, but we are piloting a more formal academic partnership we announced last year with the University of Tennessee. So I mention this only because I do think we are asking ourselves the very same question that you are asking us, right? And we want to figure out what this future looks like of partnership between the association and universities. And so we don't know the answer yet, but we are excited for the journey and excited to figure out what this looks like going forward. So let's talk about both of these opportunities.
I mean, that's really encouraging. I think the more we can work together, the more we can learn together. We have another question.
Dan Sperling. I'm from California, University of California, Davis. I head up a big center, just like UMTRI. And I thought I'd, try to pull some of these strands together in this discussion. And you're three leaders in the automotive industry, and as kind of generalizing what Henry was saying is that looking forward, this relationship between the automotive industry and academia, that's been the question here. But asking you, okay, what do you, looking back a little bit in history and then looking forward, how do you see this trend going? I tell my grad students this is the most exciting time ever to be in transportation, with the automation, with the software-defined vehicles, the electrification. I mean, this is really, an extraordinary time. I know that creates pressures and problems for you all, but this is a really important, pivotal time in the history of the industry. So I'd like to ask you, okay, looking forward, what do you think makes sense as a good partnership relationship? What's the trend that you'd like to see? You can say what you think is likely, but I think more interesting, what do you think it could be or should be going forward? And I've been around a long time, so I remember when GM had this massive internal R&D program that did almost everything and basically got rid of that and formed stronger relationships, especially in the Midwest with Michigan and some others. So anyway, can you talk about where you think this would be a good trend going forward that makes sense both for the industry and academia, even if it might not happen?
So I guess I would love to see stronger partnerships where those students are in my lab just working because we have equipment that you don't have here and they could just come participate. But I also want to think, we're sitting here at U of M and you're talking about, the top of the top students and ones that are going to grad school and everything else. A couple years ago, we just announced this MSTAR partnership and it had University of Michigan, IMEC, GM was part of it, but we had Washtenaw Community College as well. So I think we need to figure out a way to not only have the grad students working in our labs, but also the people that will be our technicians and others, coders, working with us as well. And that would be amazing. Like that buzz of having all kinds of students in the labs working with us that would be a wonderful future. And I think that then it's not so much a us, them, let's join this, but like, let's kind of go after this together, you know, and pull in Wayne State or, you know, other places to really kind of make that super strong.
Yeah, I think maybe just to add to that, like we're not in an environment of infinite resources, you know, none of us, right? And so I think the trend for the future is going to be more and bigger collaboration. So maybe not just a one-on-one partnership, but like looking for other partners that can contribute skills or resources in different areas. And so that's how I would be thinking, like not just, you know, Ford, University of Michigan, but what's the bigger partnership?
Yeah, I agree with that. And then I also think, you know, that you were mentioning sort of the days where there were giant R&D organizations within the companies. And I don't see that going back to that anytime soon, right? So obviously there's really robust and significant R&D functions in all these companies, and that there will always be, I think. But sort of, I think the companies will continue to be very reliant on working with outside folks to sort of do their R&D work.
Yeah, and maybe even beyond that, it's a more distributed engagement. So if you went back, like you mentioned, 30, 40 years ago, we had a monstrous R&D center. We still have that R&D center that's smaller, but we now have a lot of people in the mainstream company with PhDs that are doing research-ish, advanced type work, especially in software and others. So it's collaborating not just with what you traditionally think of as the R&D organization, but the larger company as well, where some of that advanced work happens.
You know, you talked about how, I think it was Paul that talked about how important it was for professors to get along and, you know, work together. How do you view multi-university partnersdes? Is that are you interested in that, or is that just sort of more challenges?
Absolutely. I mean, one of the most fun projects I had the professor from University of Texas, but we had a project at Brown. I had somebody from Ben-Gurion University, one from McGill, and we would get together and solve a problem. And they all had something that they were excellent at and put together. In this case, it was like a multi-scale model for materials, but I had all that expertise. It was wonderful. So I think absolutely that's something that we could explore.
Mm-hmm. Hilary okay. Other questions? I have time for one more question. All right.
Hi, my name is Prasad, and I had the pleasure of knowing several of you, having lived long enough and having retired twice, most recently from the Center for Automotive Research. This has been a fascinating, mind-opening discussion, all of you. And I just wanted to say that we are sitting at a really fascinating juncture, 1916, fish lay, gasoline engines. How about 2026, physical AI engines? Henry, you know, I think AI is everywhere, but physical AI, and really, how do you bring that home? And along with that comes this opportunity. We're sitting against a backdrop of a roughly 113 or so $1 trillion nominal GDP economy. And there's probably a few missing years between, you know, you have UMTRI and you have the $113 trillion global nominal worldwide annual economy. I think there's a fascinating opportunity to bring the great power that Michigan has, Michigan engineering has, and holistically, the university across, whether it's working across different schools or across universities in the nation, to bring that, those missing gears together to really tie that $115, $16 trillion annual nominal GDP to moving people and moving goods, right, in a safer manner. So it's fascinating. Thank you all. Henry, Emily, good to see you all.
It's good to see you, Prasad, and you just reminded me, I'm starting to feel like literally everybody in this room also has a Ford connection, so that's amazing. 7 degrees of Ford today.
Do you all have any comments to Prasad's comments? Any thoughts?
No, just agree.
Yeah, makes sense.
I agree with him, like I always do.
Okay, all right. All right, I think we are going to come to a close. I learned so much during this panel. I hope the audience, I hope you all have as well. I want to thank our experts. I mean, we covered education, we covered basic research versus applied research, partnerships, how to work better together, tips on how to, get involved with industry. We talked about AI, we talked about, science. I mean, it was a fascinating panel, and it only was fascinating because of because of the three of you and because of the audience's participation. So I want to thank you so much for the time and energy you spent in putting together your remarks and answering our questions today. And, please, I'd say, audience, let's give this panelists a round of applause. Thank you.